I'm going to start a few minutes early, and this brings up the possibility of ending a few minutes early, depending on how I'm doing. But we left off last time with this piece in a review, kind of, we could say. First thing we found, or first thing we recognized, is this velocity is going straight down. Um, we decided that we would find the instant center of this triangle here. Consider it a rigid body, for that matter. You could consider this whole thing as if it was a rigid body. It turns out that it appears to be rotating about that instant center point. So we had to find our distances. Our distance here. That got us enough information for us to get the velocity of B right here. After we did that, we recognized we needed to find one other distance right here, and I'm not sure I did that correct. And from that, we ended up getting this value here. And as I look at this, I realize that doesn't seem quite right, but it could be that I was correct. We will go with it for the moment because we're about to go check it the other way. The other way being, hang on a second, let me see. I'm going to take a pause for a minute and look for my other, hang on. Well, just do what I can here with this. It's not exactly what I want, but okay, I'm back. So with this, we write our velocity of point B as the velocity of B relative to A plus the velocity of A. Sorry if I'm occasionally coughing during this. We end up with a velocity, whoops. Okay, hang on. We end up with the velocity of B equaling to I, J, and K. Currently, we do not know this. So, omega, here, let me do it this way. A, B, C. Then the next is to find that a vector that originates at A and is drawn towards B, which looks like that. Now, that's going to be, and let me see if I can see the, oh yeah, there, what am I saying? There's your distance. Then you've got this 60 degrees. So if you don't mind, it's 0.6. 0.6 cosine of 60. My C is a, so I don't have to write the COS. It is going to the left. And then I'm going to have it going down a distance of and then nothing. Now, I'm going to also have velocity of A just going straight down a value of what? 1.5 times J. Now, if I do a cofactor expansion, and then this term, I don't even include this cofactor expansion because the matrix that would result is going to have a 0 determinant. So just copying this down, meaning I'm going to get a velocity of B, which is plus and minus a minus, which would be 0.6 sine of 60 omega ABC I. Now this will be this plus minus a minus a minus becomes a minus 0.6 cosine 60 omega ABC J minus 1.5 J. If we want to look real close at this, what we'll find is that we can do a quick dot check, and the dot check would essentially be this number times that number plus this number times that number. And if you look at those two results, what you'll find out is, in fact, they do the multiplication of this term, and then in addition to the multiplication of that term, you get the dot product being 0. So checks out from that standpoint. Does it check out from the physical standpoint? And here's what I mean is, if you draw this as point A, I know point A is going down at 1.5. You draw this as point B, but this term is the velocity of point B relative to A, assuming that you have positive coordinate system like that, and that this is the direction. Then I'm going to get a velocity this direction, which will have a positive value in the X and negative value in the Y. Negative value in the Y, positive value in the X. So this term is as if you were basically pinning point A. Yes, point A is moving, but those two terms, these two terms in the box, are as if point A is pinned and rotating in this direction. So let's dismantle this. Okay. So now you have essentially velocity of B. And we're just going to hold off on this one for a second, except for I could go ahead, since I've already written these terms, I'm going to go ahead and recognize that the velocity of B is confined to move inside that cylinder, so it either moves to the left or right. If A is moving down, it's obviously moving to the left. I'm going to purposely assume it to be moving to the right, just so I can see what happens. And what we'll see Okay, so now we're going to break it into I and j components. First, we'll take the i's, which are this one and that one. So velocity of b is going to be equal to 0.6 sine of 60 omega ABC. The j component is going to be these two components. So it's going to be minus 0.6 cosine 60 omega ABC minus 1.5. And from that, omega ABC is equal to minus 1.5 divided by 0.6 cosine of 60. And that is going to be calculatable, and it'll give me a second, and maybe I can get that done. Let's see. I am not trying to use Chrome. I don't know what is it doing. Okay, I got 2 octaves up. Okay, there. No, it won't allow me to do that unless I come off the full screen. I get minus 5. Now, before I go any further, we have to realize this. This was x, this is y, this was what was defined as positive. So this means that omega ABC is moving 5 this way. Is this consistent with our instant center? First of all, if you look at it, this in fact is consistent with our instant center. The other question is, here's our instant center. This in fact is our velocity. Excuse me while I mute this. All right, I'm back with you. Sorry about that. So, up there, remember, or back over there. All right, x and y. This is a positive rotation, and in fact, they are going in the opposite directions. So the answer I received here is in fact very consistent with what I had before. Now, I didn't finish this up, because now one might want to know what this velocity is. And it would be nothing more than 0.6 sine of 60 times 5, or, since this is going to be very particular, minus 5 becomes we'll go ahead and do the minus 5 times 0.6 times sine degree of 60, or minus 2.598. Minus 2.598. Now, I assumed it like this, so therefore velocity of B, I assumed, in other words, I assumed it to be this. Therefore, it's equal to minus 2.598. I, meaning it actually is going to the left instead of the right. Okay. All right, so now I'm looking at fixing mode. I'm going to try to figure out what happened here. Okay, 2.598. Okay, well, it's 2.6. So roughly speaking, it's the same thing. The question is what was this term? Where did that come from last time? And that term came from 0.6 times the sine of 60, and 0.6 times the sine of 60, the same 5. So the equation is exactly the same. So I would consider that one to be a success as well. So this is good. Now, velocity of C. Here's the thing about this. Okay, this is where our problem was split as far as instant center over here and regular vector methods over here. So now what I'm going to do is I'm going to do the magic of this media to do this. Move it out of the way to make room over here to be close to that part of the problem. Here's what I mean, okay? This is all self-contained. This came in first, and now I'm going to do the second one, which actually depends on that. Here's what we're going to do. Okay. Since A and B and C are all in the same length, I could do this one of two ways. Velocity of C is equal to velocity of C relative to B plus the velocity of B. Or I could do velocity of C is equal to velocity of C relative to A plus velocity of A. Now, what's the difference between or the problem of doing either particular one of these? Let's look at each one. Okay, first of all, the omega ABC will be the same. Okay, I'm back. You get ABC crossed. I never check the audio. Hang on a second. Okay. Okay. Let me get ABC or C relative to A plus velocity of A. Now, here's your difference between either one of these. You're either going to have to find this vector or you're going to have to find that one. You already know this one. You already know this. You already know that and that. So it boils down to which vector do you find would be easier to find, okay? Each one is a vector originating. One vector originates from here and goes to there. The other one originates from here and goes to there. I'm going to choose this one because I find that it is a much easier thing to come up with. So with that in mind, I'm going to get rid of all this. Okay. Okay, velocity of C will equal to I, J, K, 0, 0. Now, omega ABC is technically a minus 5. It's right here, but it's rotating this way and not that way, which puts it as a minus 5. Now let's see if we can figure out the other items here. Okay. So if I look at a line from here all the way to here, I find that 90 plus 60 degrees plus this value is going to equal 180. Well, that's going to put you at 90 and 60 or 150. That's going to leave you this being 30 degrees. So if you add up 60 and 30 and then 90, you're going to get 180. So with that in mind, a vector that originates in B and draws itself back to C is going to be minus 0.5 because that's the distance there. And in this particular case, cosine 30. And this one's going to be 0.5 sine 30 because it's going up. Plus velocity of B. What was velocity of B? It was that. And it is going in the backwards direction. 2.598, I believe. Now, here's where we're getting that from. So the velocity of C will end up being I cofactor expansion 0 minus 5 0.5 sine of 30 0 minus J and 30, and we'll move this over. And there is no K because if you do cofactor expansion here, what's left is a 2 by 2 with a 0 determinant. Becomes plus minus a minus term, which will be 5 times 0.5 sine of 30 I, a plus minus a minus a minus a minus. 4 minuses. 5 Okay, let's see. 5 times 0.5 times sine degree of 30 gives me this term, 1.25 plus, go ahead and just change that to cosine, 2.1651, 2.1651 J minus 2.598I. Let's take a look at this bottom term. First, let's do our dot check. This one times this one plus this one times that one. And they have opposite signs, equal magnitude. Now let's do our drawing check. And let's see. All right. If I had this thing drawn like this, whoops. This is point C, and this is point B. And you have to realize this is velocity of C, as if B were fixed. Turns out a negative rotation here is positive. So it is rotating as such. As a result, you're going to get a positive X and a positive Y. Positive X and positive Y. So in fact, this is it. This is the velocity of C. So let's go ahead and subtract this one from that one. Okay, 1.25 minus 2.598 is equal to minus 1.348 minus 1.348 I plus 651J. Its magnitude squared. So let's find that out. So let's do a square root of 1.348 squared, 2.1651 squared, 2.55, about 2.55, okay, 2.55, that's what I get for the magnitude. Let's see. That's what we got here. Now, let's start making headways towards our accelerations. The best thing to do here, I think, is to copy the picture and move down the page, knowing that I can look back at any point at any of this. I'll do so kind of like that. So I'm going to pause and get a drink of water here. All right, here's the thing about the accelerations that can be annoying. You have a check for the velocities, meaning you can use the instant center or the vector equations. For accelerations, you don't have instant centers, you only have the vector equations. So we're going to have to use them. So what we'll do is we'll move to finding the acceleration of b is equal to the acceleration b relative to a plus the acceleration of a. Acceleration of a is given here. Since we're using the vector equations, we're going to have to stick to this nomenclature here. And what we're going to have to do is realize this is only due to rotation. So with that in mind, it's going to be alpha A, B, C, because that's the entire length, cross R, B to A, minus the centrifugal part. And this is why you can't do this. So here's the magnitude of the omega squared times R BA plus the acceleration of A. Now what is so nice here is that I have a copy of this to fill out this. I already have an equation right here, and this was it. C, nope, this was it, B to A. So I could essentially copy these terms, and then I can double check them. Now, this is not going to fit quite right, so I'm going to put them right there. So I could just slip them right in there. But let's double check them now. Is this the vector that originates at A and points to B? There is that vector. Has a component here and a component going down. This one is 0.6 cosine of the 60, 0.6 cosine of the 60, and this one is 0.6 sine of the 60, and it's pointing down as well. So in fact, since I've done this vector equation before, that's what we get. Now the omega ABC, I believe, was 5. Now we don't care whether it's positive or negative. And now I just simply copy this vector right there, meaning minus 0.6 cosine of 60, I minus 0.6 sine of 60, J plus the acceleration of A, which is down so I have my centrifugal part. I have the movement of the end, and then I have the other. I can also say, and I'll take this moment to say this, I'm going to assume that the acceleration of B is to the right. I'm pretty sure it's not, but that's okay. I'll say it's acceleration at B times A, and I just made it capital so that it'll look different than that. Now, let's do our covector expansion like stuff here. And what I'll do, acceleration of BI is equal to I times, here I'm going to start using the magic that I can. Here you go. Use the magic when you can. Notice I was able to eliminate out the middle in there. In other words, this one is that, and this one is that one. Now, I really need to multiply all this out. So I will go ahead and do that. So first of all, I've got 25 on the outside. And I might as well carry the sign. And this 25 times, but everything is a minus, in other words. So I think I'm legitimate in dropping everything. 25 times 0.6 times cosine degree of 60. 7.5 for the first one. And not going to be such a nice number for the second one. 12.99, but and we'll say it's 13J minus 0.5J. Equals to this and that. Second one being a minus, but it's already a minus. It's going to be alpha ABC 0.6 sine of 60. That is going to be the I component. A minus is a plus, and another minus on this one, so it's going to be a minus alpha ABC 0.6 cosine of 60 J minus 7.5I plus 12.5 J So, what do we do now? Break it into the I component and break it into the J component. First one would be acceleration of B. Then I'll get this term, and this term for the I, alpha ABC 0.6 sine of 60 minus 7.5. 0 for the J, because there is no J over here. Now I'm looking for this term to go with this term. You know, myself, I live amongst the matrices, but in this, I'm going to go ahead and take this one and I don't know what that's going to be. $41. Then I'll be able to take the AB equaling to this 41, because I'm going to take the 41 and stick it back in here. Then I'm going to take this equation and put it right there. 41.6666 times 0.6 sine of 60 minus 7.5. Okay, let's just use that. Okay, A times 0.6 times Sine degree of 60 minus 7.5, 14.151. Okay, now, in light of this, I'm going to take a pause for a second and go find the solution. Kind of surprised because it was, I thought I left on that problem. There it is. 126, 16, 126. Now, here's something. I think I've done this before. Let's see. Okay. Okay, so I'm still right there. 16, 126. Seems to maybe go to the top of that section every time. That's okay. I'm sorry for the long delayed okay 126 16 126. Okay, so there is our 41.6. There's our alpha. Okay, wait a minute. I don't want to. So that's where we kind of left off. Oh, but acceleration. There was our alpha, 41.6, 14.151. 0.15. Oh, he got a different answer here. Let's see what I did wrong. Oh, wait a minute. 38. Whoa, whoa, whoa. Okay, hang on. I'm not done with the thing. Wait a minute. That's the acceleration of B. What does he want? He wants the acceleration of C, and I don't care about the angles. So I thought he was looking to find, okay. Okay, and the acceleration into C, okay. So I still have that one more part to do. Okay. So in fact, checking the back of the book, we found that this is correct. We did not even need to know this. Not needed. So let's go ahead and wrap up with finding the last part. And so, in essence, we can do this. And we'll just move it to the right. We will say this is its own entity here. And our issue is that now we need to find acceleration of C is equal to the acceleration of C relative to what? B or A, because they're all in the same link. Again, since I did this the last time, where I related C to B, I looked at that distance versus this distance. I can find it either way, but I'm going to relate it to B plus the acceleration of B, which I believe I found right here. Okay. Now the other thing I want to check on is if you look at that, he has this little descriptor right there. It rotates that way. So in fact, let's see. That is a positive. It is counterclockwise. What did he say? Oh, we have them both in the same direction. Okay, so this checks it out from both the magnitude and the direction of rotation. And so it seems interesting that's the acceleration, even though, think about this. Thought for the day, both the acceleration and the velocity are positive down. From the velocity standpoint, we found an instant center which sat right here, and it was as if that. So that means the velocity was going this way. Now, here we have an acceleration that's positive this way, and because of the fact that there's centrifugal components here, we have an acceleration going that way, meaning B has a certain velocity, but it's slowing down. That is interesting and basically can be disorienting a little bit, because what I'm saying is I assumed the acceleration to be positive in this direction. In fact, I get a positive number, so therefore the acceleration of B is in fact going that way. A little bit different, but a subtle point that visually is incomprehensible. Okay. Alpha, A, B, C, which I already have. Hang on. I don't see anything there. Which I already have. Crossed R, C, B, which I had before, and I'm going to use it again. Minus Mega ABC, which is still the 5. And so what we get is I, J, K, 0, 0, 41.6667 from right here. Then C to B, let's take a look at that. When we were up here using the velocities, guess what we did? We found that. This is what we found. So what we're going to do, going to do a copy because we had it before, and then what we're going to do is a little check. Yeah. There we go. Minus, this time I'll go ahead and put the 5 squared times minus 0.5 cosine of 30i. I'm simply copying these terms across. Plus 0.5 sine 30j. Uh-oh, I'm running out of space. Plus acceleration b, which I actually have back here. This is this 14, but I don't have enough room to put it right now. Unless I did this. Here's what I'll do. Okay, 14.151. Okay. All right. Acceleration is C, just straight up. I don't know what it is. This is a cofactor expansion, which was incorrectly copied. Should have just did that from before. Minus J. Okay, 41.6667 minus 0.5 cosine 30. And I think it's time to start figuring out these numerically. So let's start here. I'm going to go ahead and figure out this value and go ahead and add it to that. Okay. Minus and a minus. These two terms are plus, so I'm going to just say 14.151 plus 25 times 0.5 times cosine degree 30 gets you 24.976. Okay, that'll be the I. And now what we're going to do next. $6.25. This is sine. Okay, minus, because this is a minus and a minus. Minus 6.25J. So now I'm going to have to do this times a minus. Okay, so let's go ahead and do that. 41 point this times 0.5 times sine degree of 30. That is not a time symbol, but that is. That would be 10. Okay. 0.417i. And then 41 times the other. Now, that's a minus. Okay. Let's do the other one. $18. 4, 2. Now, this is two minuses, a plus and a minus again. This would be the J. So what do we end up with? The acceleration of C is equal to, okay, 24.9. Okay, let's see. Was this the case before? In other words, you get two minuses out of the other. Just bear with me for a second. Okay, wait a minute. What is going on? Okay. So in other words, here's my question. Out of this becomes this. Out of this becomes this. We have minus terms on both. Okay, one is almost twice the size of the other. Yeah, that's about right. Okay. Now, my final thing is 24.976 minus 10.417 gets me about 14.559. $14.599 minus 18.042 added to 6.25, 24.292. And I think he wanted the magnitude. So if I look at the square root of the squares, 24.292 squared plus 14.599 squared 28.341. That's the magnitude. 38.2. Is that what I get? 38.2. 28. Oh. I think if we've got a problem here, I think I've gone too long anyway. So we will figure this out later. 38.2 is what he's got. So we're going to try to solve that one or fix later. Here's what we'll do. Answer is 38.2. And we're going to look at it like that. He says 38.2. And the angle down to the right is 39.4. So this is what he claims the answer is. I have reached the point of exhaustion. So we will look at later. So I'm going to call it quits here. Unless, let me just look for a second. Let's see, 14. Let me just stare at this a minute, run some numbers using my calculator out of hand here. I may do it this way. I'm just going to double check it this way. Okay. Here's what I'm going to do. Okay. R CB minus 0.5 times cosine degree of 30. Is that correct? I think so. And then 0.5 times sine degree of 30. And then what we'll do is alpha is equal to vector, which is 0, 0, and 41.6667. And then omega will be a vector, which is 0, 0, 0, 0, and a minus 5. Now, if I do this as a vector equation, I'm going to have to add the AB to it as well. Acceleration of B, which I don't think I put in there. Maybe I did. Okay. acceleration of B, which will be equal to 14.151, 0 and 0. Okay. If I were to write this acceleration to C, it would be cross. Okay, I've already forgot. What was it? Alpha LPHA cross with R CB plus cross of, what was that called? Omega. And then in there would be cross. What is this dumb thing? Don't want that. Cross Omega cross RCB. And then add acceleration of B. So it looks like I did all the math correctly. Huh. That's weird. Where did it go? What is going on here? I don't know what's happening. What is happening? Okay. Okay. Bring it back. Go to here. All right. Okay, so this is what I get. This is what I get for acceleration of C. And then if I do the norm of the acceleration of C, I get 28. Well, ladies and gentlemen, unless I am seeing something definitely wrong, meaning, okay, let's see if I can go back and double check. Omega is in fact -5. That's what we came up with before. AB. So I'm going to conclude that I think that my system is correct. We have several things that could go wrong. First of all, 41.667, that's what he had in his solution, 41.667, going in the correct direction. We can do another check of the tangent of the two angles, meaning we go to the right one and down, so 14 to the right, it's 0.252429 down. So I'm going to stick with my own answer and say it's possible. And instead of 38.2, it was supposed to be written as 28.3. 38.2, so somehow maybe the 3 got interchanged there. So I'm going to go ahead and stick with my own answer and call it a lecture.